Record.
Amazing.
Okay, yeah, now it's recording. If I get the record at the end of the day, I'm not sure, but yeah, for now it's recording. So yeah, I'm Alex from Answer. I will quickly introduce myself and then we can go through the presentation. So I have a background in battery modeling. I did every kind of modeling battery for the last 7 years. From electric equivalent circuits for a startup that was working to connect community to the grid in the Tanzania mainly. Then I did many electrochemical models, both DFN during my master, but also interface models, both for lithium metal and for lithium sulfur batteries. And how did I came in contact with AI? Because, I mean, from my background, I wasn't supposed to know it. It was actually in 2020, it was pandemic, felt bored a bit, but also I had many problems with my PhD. So I was doing some dendrite simulations and I was using COMSOL. The simulation were crashing a lot. And so I read this paper that said, and they were crashing because of mesh issues. And I read this paper that said there is a meshless technique with AI. And I say, okay, this is what I need. Yeah, unfortunately, I didn't find the solution for my dendrite problem, but I came in contact with AI. I started to study it from Coursera, which I think is very valuable resource. And then I go deep and deep. I worked a bit of using like LSTM or recurring neural network for estimation of SOX, both SOC and SOH. And then last year actually, I started to work with large language models, which is like this new thing in the world of AI. So this is the presentation that we're going to have today. In the spirit of Battery Brunch, I want to keep it open. So I hope we can dedicate a lot of time for open mic, in which you can also give your feedback, both of the presentation, but also on the open questions that we have. But first, I want to talk about the history of LLMs. I'm trying to keep it like not very technical, just so everybody could appreciate what's going on. Then I will introduce some examples of people that I know that are in the battery industry and try to use LLMs. Then we will do a demo of what we are working on at Answer. And lastly, as I said, it's open mic, so feel free to speak up and yeah, give feedback or just chat with each other. So, sorry. Okay, history of LLMs. Despite I'm very enthusiastic about this sector, I want to start by saying, I mean, it's not magic, it's just statistics. Language model is the field of predicting the next word in a word sequence. It's statistics. It has some emergent properties, but at the very basic statistics. So no magic involved. And so it's all about probabilities. But yeah, let's go to the very history of LLMs. So LLMs start very early with respect to their popularity. They start in the 60s at MIT when the very first chatbot was made by what's called Elisa. It was very rudimental. As you might know, AI was quite cool in the 60s. Then they discovered that there were a lot of constraints due to the hardware. So it went to what is called AI winter from the 70s to the 90s, in which there was not much progress because the theory was wrong, but it was useless. There was not the hardware in it. So almost after 30 years, in 1997, we have the next breakthrough, which is the introduction of LSTM, that stands for long short-term memory. And it's a type of recurrent neural network, but it was still just for data. LSTM, RNN, they're used for time series. For instance, also in the world of batteries, as I said, you can apply them if you have a sequence of SOC or SOH. And there are many papers that are about this, started from 2017. Some of them try to combine also with like more traditional technique, like Kalman filters. I think the industry is still towards the Kalman filter, but hopefully we will see a lot of more introduction about this new technique. And yeah, in 2010, there was the first application of this thing in NLP, sorry. So this was able to do sentiment analysis, which means to understand what a sentence is about, but it was still in the early phase. Then Google Brain started in 2011. It has more advanced feature like word embedding that we will talk about later, which is like a numerical representation of the word. And this was good because it gave the opportunity to understand the meaning of words and understand the relationship between words. But the very breakthrough in this sector happened in 2017 with this exactly paper, which is, I think it's going to go to the history as maybe one of the, I don't know, papers that changed at least science, let's say. I think for neural network, it's the equivalent of what Einstein wrote in, I think it was 29. The paper is called Attention is All You Need. It was made by a team of researchers at Google in, it was in collaboration also with the University of Toronto. And thanks to this breakthrough, we can have now tools like ChatGPT. What happened in this paper was the introduction of this mechanism that is called attention. And attention, it was really the thing that make you understand how the words are connected between each other. Because before with RNN, to do that, you needed a lot of computing power, while with this new approach, it is easily scalable. You can use multi-core GPUs, and it can parallel process input data. So to understand better, I have this image here. So this is, let's say, it's a very simple phrase. But here you can see the difference between RNN, LSTM, and transformer. So the RNN, it's very basic. You have that each word has a connection with the previous word. So in the, at the end of the day, this is the field of like predicting the next word or the next data point if we are doing something more scientific. And this way, it's very inefficient because you need a lot of words before to get the next word. Then it was introduced the LSTM, long short-term memory, which it has the advantage with respect to the RNN that it maintains the dependency of the words throughout the length of this sequence. This is also very cool, for instance, for batteries, because sometimes you have events that happened much before than what your current time, and you need this current time to maintain the dependence from like the previous event, so you have more connection between. But the real game-changing breakthrough happened with transformers, in which the words, they are not only connected between each other. I mean, I'm talking about words, but this could be like number of time series as well. But there is also this mechanism that is called attention, that is like a weight on how the words are connecting between each other. So if two words are very connected, there is higher attention. And this is like the game-changing thing, because it is able not to have, it is able to understand the context in which this thing happened without needing a lot of input before, without needing a lot of computer usage. at the end of the day, it's, as I said before, this is statistics. So why this emergent property happen is because each word is embedded. Embedding it means to give a series of number to a word. In this specific paper, this vector of numbers was 512. The way that we can think about embedding is like, I cannot arrive to say 512 attributes to a word, but I can say like 2 that could be like good or bad, or material against, I don't know, like object against human. So like if we build this matrix, you can put each word that you have in mind in one of this category, like on this 2D plane. But of course, just two attributes, they are not enough. So you need more. And so in this paper, they did it with 512. I think currently ChatGPT has even more attributes, which I think they don't have any human meaning. It's just a way to represent the words. This is the embedding. And of course, you also have an embedding that is due to the position of the words in it. So yeah, after this paper happened in 2017, there was a huge growth of different neural network. Many companies entered the space. We have Google, OpenAI, deep learning, Meta, Huawei, everybody are entering the space. And even now that it's even more open, because training this huge neural network is getting cheaper and cheaper. And another trend that you might recognize is that this LLM is getting huge. So the L in LLM stands for large, of course. And we have seen that they are getting more bigger and bigger and bigger. But I think that I think they don't tell you at the TV, let's say, or it's less known, is that bigger, it's not always better. Indeed, I think in 2022, a paper was published by DeepMind, and it was called Chinchilla, in which they published this model called Chinchilla. So this is called Chinchilla rules. And it says that to have optimal training of a neural network, you have to feed it a number of tokens that is 20 times the number of parameters. So a number of parameters is how many weights there are in the neural network. Tokens is the way in which a document is divided in order to be fed to the neural network. So this has to be around 20. And for instance, they've seen that that GPT-3 and GPT-4, they have a huge number of parameters, but they are undertrained. So even they need more training, or like they're using too many parameters, so it's not efficient. And so there is these rules about having 20. There are also other cases. One particular case that we can also think about in the battery space is neural network that are like specific to one sector. And I want to bring the example of Bloomberg GPT. So this Bloomberg GPT was made by Bloomberg, and it was specific tailored for the finance world. Let's say the finance jargon is quite different from common jargon. So I think they really need to recreate a model for that. And they wanted to follow these Chinchilla rules of having the number of tokens that was like 20 times the number of parameters. But surprise, surprise, there was not enough data in the finance world to do that. So they end up having a model that was still suboptimal, which is kind of crazy, because I mean, like 10 years ago, we had all of this data and everybody was saying data is the new gold. There was this gold rush. it was like big data everywhere. And now 10 years later, it seems like maybe we didn't have so much data in specific sector. That's a little bit crazy.